Hi everyone, in this video we will take example about how to find the vertical asymptote lines and horizontal asymptote lines. In part A we have the function f of x equals x minus 3 divided by x squared minus 9. And to find the vertical asymptote line, this means you have to check what are the zeros of denominator after simplifying. So you have to simplify the function, then you have to take the zeros of denominator. So our function f of x, we can write it as x minus 3 divided by, now x squared minus 9, it means x squared minus 3 squared, which is a difference between two squares. So we can write it as x minus 3 multiplied by x plus 3. Now you have to simplify the function. You have to cancel x minus 3 with x minus 3 and you will get 1 over x plus 3. So you have to take the zeros of denominator after simplifying. Then we have x equals to negative 3. This is the vertical asymptote line of our function. Now what about the horizontal asymptote line? Now the horizontal asymptote line means you have to limit the function at infinity and negative infinity. So it means limits at infinity and negative infinity. So you have to find limit f of x when x goes to positive or negative infinity. So this is equals to limit. As you know, when you have to find the limit at infinity and negative infinity, you have to take the highest power up and the highest power down. So we have x divided by x squared, and you have to cut the other terms when x goes to positive or negative infinity. Now this is equals limit 1 over x when x goes to positive negative infinity, and 1 over plus minus infinity equal to 0. Any number divided by infinity or negative infinity equal to 0. Now since the limit at infinity equals a number which is 0 in our question, so y equal 0 is the horizontal asymptote line of our example. Now in part B we have another function h of x equals 6x cubed minus 10x divided by 6x cubed plus 5x squared. And you have to find the vertical asymptote lines and the horizontal asymptote lines. And how to find this? Firstly, you have to find vertical asymptote by taking the zeros of denominator after simplifying. So you have to simplify the function. So h of x equals, in numerator we have a greatest common factor which is 2 between the numbers, and between variables we have x as GCF, and you will get 3x squared minus 5 divided by, what about denominator? We have x squared as greatest common factor, and you will get 6x plus 5. So cancel x with x, you will get 2 multiplied by 3x squared minus 5 divided by x multiplied by 6x plus 5. Now you have to put the denominator equal to 0. So you have two solutions. The first one, x equals 0, which is the first horizontal the first vertical asymptote line, and we have 6x plus 5 equal to 0. By subtract 5 from both sides, you'll get 6x equals to negative 5. Then we get x equal negative 5 over 6, and this is the second vertical asymptote line. Now what about the horizontal asymptote line? the horizontal asymptote line means you have to take limit of the function at infinity and negative infinity. So limit h of x when x goes to positive and negative infinity equals limit the highest power up divided by the highest power down. So we have 6x cubed divided by 6x cubed when x goes to positive negative infinity. Cancel x cubed with x cubed, you will get 6 over 6, which is equals to 1. So the horizontal asymptote line for our question is y equals to 1, and we have only one horizontal asymptote line. In part C, we have g of x equal x squared plus 3x plus 1 divided by 4x squared minus 9. And as you know, we can write the denominator as 2x all squared, and we can rewrite 9 as 3 squared. And there is no factorization for numerator. So the factorization of the function g of x is x squared plus 3x plus 1, and denominator is a difference between two squares, so it will be the first one minus the second one times the first one plus the second one. Then you have to put denominator equal to 0. We have two equations, 2x minus 3 equal to 0 and 2x plus 3 equal to 0. By solving these two equations, you will get the vertical asymptote lines. So we have the first one, 2x equals 3 and x equals 3 over 2, which is 1.5. And this is the first horizontal asymptote line. By solving the second one, you will get 2x equals to negative 3, divide by 2 both sides, x equal minus 1.5, and this is the second vertical asymptote line. Now, in the second part of part C, we have horizontal asymptote line. And how to find the horizontal asymptote line, you have to take the limit of this function at infinity and negative infinity. So you have to find limit g of x when x goes to positive and negative infinity. And as you know, when you have polynomial divide by polynomial, when x goes to infinity or negative infinity, you have to take the highest power up divided by the highest power down. So we have x squared divided by 4x squared when x goes to positive and negative infinity. By simplifying x squared with x squared, you will get 1 over 4. So the horizontal asymptote line is y equals 1 over 4, and we have only one horizontal asymptote line. In part D, we have y equals 6x times x minus 2 times 2x plus 3 divided by 6x minus 1 times x plus 2 times 2x plus 5. And here, the factorization of the function is already done for this question, and there is no common between numerator and denominator, so there is no simplify in this function. So directly you have to put denominator equal to 0 to find the vertical asymptote line. So put denominator equal to 0. So we have three equations, 6x minus 1 equal to 0, or x plus 2 equal to 0, or 2x plus 5 equal to 0. Solve these three equations, you will get three vertical asymptote lines. For the first one, we have 6x equals 1 divided by 6, you'll get x equals 1 over 6. This is the first vertical asymptote line. And here move 2 to the right hand side or subtract 2 from both sides, you'll get x equals negative 2. This is the second vertical asymptote line. And the last equation, you have to subtract 5 from both sides, you'll get 2x equals to negative 5 divided by 2x equal minus 5 over 2, which is minus 2.5. So this is the third vertical asymptote line. So for part D, we have three vertical asymptote lines. Now, what about the horizontal asymptote line for this function? Pay attention for this part, because in horizontal asymptote line, you have to take the limit at infinity and negative infinity, and so you have to multiply the brackets in numerator and denominator to get the highest power. So to find the limit of the function y when x goes to positive and negative infinity, you have to take the highest power up. Highest power up means 6x multiplied by x multiplied by 2x, which is 12x cubed. So we have limit 12x cubed divided by 6x times x times 2x, which is 12x cubed also. When x goes to positive and negative infinity. By simplifying, you will get 1. So we have y equals 1 is the only horizontal asymptote line. In part E, we have the function g of x equals sine x over x. So to find the vertical asymptote line, you have to take series of denominator after simplifying, and there is no common between numerator and denominator in part E because we have trigonometric function up and a polynomial down. So directly you have to take x equal to 0. But pay attention here. If you take x equals 0 and find limit g of x when x goes to 0, you will get limit sine x over x when x goes to 0. And as you know, this is equals to 1. Since the limit when x goes one of zeros of denominator not equal to infinity and negative infinity, so x equals 0 is not vertical asymptote line. So zeros of denominator, you have to take them and compute the limit at this 0. If you get a number, so it is not vertical asymptote line. If the limit goes to infinity or negative infinity, it will be a vertical asymptote line. So there is no vertical asymptote lines for this question. Now in the second part, which is to find the horizontal asymptote line, you have to take this limit at infinity and negative infinity. So you have to find limit g of x when x goes to positive and negative infinity. Now here, this means that we have limit sine of x divided by x when x goes to positive and negative infinity. Now pay attention here. Now sine infinity, we cannot know or compute what is the sine infinity or sine negative infinity because we are talking about the interval from -1 to 1, because sine x is between -1 and 1. So at infinity we cannot find the exact value of sine when x goes to positive or negative infinity. So you have to use the squeeze theorem or sandwich theorem to find this limit. So as you know, sine x is between -1 and 1. Now divide by x. When x positive, when you divide, when x is greater than 0, which is or goes to infinity, to be more precise, x goes to positive infinity. Goes to positive, so x is a positive quantity, so divide by x, divide by x. There is no change in the sign of inequality. Now at infinity, 1 over infinity goes to 0, and when x goes to infinity also 1 minus 1 over x goes to 0. Since sine x over x at infinity is between 0 and 0, so this limit equal to 0. With the same manner, you have to deal x goes to negative infinity. We have sine x is between -1 and 1. Now you have to divide by x, but x here, when x goes to negative infinity, x is a negative quantity. So when you divide by x, you have to change the sign of inequality, and you will get greater than or equal, greater than or equal, and you will get the same thing. 1 over negative infinity equal to 0 minus 1 over negative infinity equal to 0. So in the two cases when x goes to infinity and x goes to negative infinity, by squeeze theorem you will get that limit sine x over x when x goes to positive and negative infinity equal to 0. So we have y equal 0 as the horizontal asymptote line for this question. Now in part E we have the function y equals e to the 1 over x. There is no simplify for 1 over x. It is in simplest form. So directly you have to take the zeros of denominator. This is the denominator, which is x. So you have to take x equal to 0. Now you have to compute the limit when x goes to 0 to check if it's go to infinity. So limit e to the 1 over x when x goes to 0. From right first, the equals e to the power 1 over 0 from right. And 1 over 0 in general equal positive and negative infinity, but since we have 1 over 0 from right, it will be e to the power positive infinity, and this is equal to positive infinity. Now if you compute limit e to the 1 over x when x goes to 0 from left, you will get e to the power 1 over 0 from left, and this is equal e to the power negative infinity, and e to the power negative infinity equal to 0. No problem, since 0 from right, x goes to 0 from right, the answer is positive infinity, so we have x equals 0 as the vertical asymptote line. Now what about the horizontal asymptote line? You have to compute the limit when x goes to positive and negative infinity for the function given in the question. So limit y of x when x goes to positive or negative infinity, this is equals e to the power 1 over plus minus infinity, and 1 divided by plus or minus infinity equal to 0. So we have e to the 0, which is equals to 1. So y equal 1 as the only horizontal asymptote line for this function. In part G and H we have ln function, which is natural logarithmic function. And in general, you have to, if you have to find the vertical asymptote line for logarithmic function, any logarithmic, you have to take the function inside the logarithmic function and put it equal to 0. Then directly you will have the vertical asymptote line. So for part H we have the function of x equals then x squared minus 3, and to find the vertical asymptote line, take the function inside x squared minus 3, put it equal to 0, solve it, and you will get directly the vertical asymptote line. So we have x squared equals to 3, take square root for both sides, so we have absolute value of x equals square root of 3. Then we have x equal square root of 3, and x equals negative square root of 3. This is the first vertical asymptote line, and this is the second vertical asymptote line. Now how to find the horizontal asymptote line? You have to find the limit at infinity and negative infinity. So you have to find limit f of x when x goes to positive and negative infinity. So this is equals to limit ln of x squared minus 3 when x goes to positive and negative infinity. Now replace infinity in our function, you'll get ln of positive minus infinity squared minus 3. Now plus minus infinity squared, it will be plus infinity, minus 3, it will be infinity. So we have ln of infinity, which is equals to infinity. Now since the limit at infinity and negative infinity equals infinity and not equal to a number, so there is no horizontal asymptote line for this equation. Now in part H we have the function ln of x squared minus 1 minus ln x squared, and as you know, you can simplify by use the quotient rule of logarithms. So when we have ln a minus ln b, we can write it as ln a over b. So we can write this function as y equals ln of x squared minus 1 divided by x squared. Now, as we did in part G, you have to take the function inside the len or the logarithm, any logarithmic function, and put it equal to 0. So x squared minus 1 divided by x squared equal to 0. 0, we can write it as 0 over 1. And by cross multiply, we have x squared minus 1 times 1 equal 0 times x squared, which is 0. Add 1 to both sides, you'll get x squared equals to 1. Take square root for both sides, you will get x equals 1 and x equals to negative 1. So this is the first vertical asymptote line, and this is the second vertical asymptote line. Now, to find the horizontal asymptote line, you have to find the limit at infinity and negative infinity for the given function. So limit our function y when x goes to positive and negative infinity equals limit len of x squared minus 1 over x squared when x goes to positive and negative infinity. Now here we have polynomial divided by a polynomial, and x goes to positive and negative infinity. You have to take the highest power up and the highest power down. So we have limit len of x squared divided by x squared when x goes to positive and negative infinity. This cancel with this, and you will get len of 1, and len of 1 equal to 0. So we have y equal 0 as the horizontal asymptote line of our question.